Circuit is a PCB prototyping machine. That's a desktop-sized CNC machine which allows production of a printed circuit board right on your desk. There are various add-ons available for the machine that are capable of insulation milling, drilling, solder paste dispensing, and S&D components placement. To demonstrate the capabilities of the machine, we will produce a PCB with an accelerometer, RGB LEDs, and an MCU, which will control the LEDs depending on which way the board is inclined. The board was designed in Eagle. Here's the board schematics and layout. The layout was exported to Gerber files. Gerber files with the board layout are opened in CircWizard. That's an open-source, cross-platform software which controls PCB prototyping machines. The PCB that is going to be milled is fixed in the machine with 4 pins. This serves two purposes. The pins hold the PCB in place while it is being milled and drilled, and provide a way to remove the board from the machine and put it back on the exactly same place, which is crucial for double-sided boards. This screen shows the traces that will be milled on the top layer. When everything is ready, click on the Go button, sends the program to the machine, and it starts milling the traces. The tool follows the outline of every trace on the board and isolates it from surrounding copper. One by one, every trace is isolated. There are tools with different diameters. This one has a conical shape and its diameter is 0.2 mm at the tip and 0.5 at its widest part. It took slightly over 10 minutes to mill the top layer. Sometimes copper residues can be left on the traces. It can be seen on this board. Those can be removed with a very fine sandpaper. It needs to be really fine, otherwise the board will be scratched. Then the board needs to be cleaned and preferably rinsed. That's what it looks like after finishing and cleaning. Now the bottom traces need to be milled, so the board is flipped to the other side. Because of the pins that hold the board and the machine, the software can automatically calculate the location of the traces, and there is no need to align anything manually. That's the bottom layer of the board. Again, click on the Go button, starts milling. The operation is essentially the same as the previous one. There are less traces on the bottom layer, so milling will take something like a minute. We are using the same tool again, as there are no small traces here. The bottom layer is also ready. Next operation is going to be holes drilling. Because drill bits have to go through the board, this time there is a spacer between PCB and machine's bed. Otherwise, drill bits would damage the machine. The software asks for a drill bit. Those are the holes that will be drilled. Clicking on the Go button starts drilling operation. These are the holes for the vias connecting top and bottom layers of the board. They're drilled with 0.6 mm drill bit. The board is almost ready. The last machining operation that needs to be done is contour milling, to get the board out of the laminate. As the components will be placed later, the board can't be removed completely yet. There are small tabs in the contour milling path. These are small enough to be easy to break, but sufficient to ensure that the board stays in one piece as long as it is needed. Contour milling is a dirty operation. It produces lots of dust. Now milling and drilling operations are finished. It's time to populate the board with components. Before placing SMD components, solder paste needs to be dispensed on the pads. So now there is a syringe with solder paste instead of spindle in the machine's head. This screen shows where the paste is going to be dispensed. Click on the Go button, starts dispensing. Sometimes a pad can be missed. It's not a big deal. We will fix it later. Now, the last step in the process is placement of the components. A tape with components is placed on the special panel. The software has calculated the location of the component on the panel, so clicking Go to Pickup positions the machine's head above the component to be picked up. Click on the Pick Up button instructs machine to pick an accelerometer from the tape. Then, Go to Target button makes the machine move the component to the location above its place on the board. The chip now needs to be lowered just above the board. This provides a better view of the alignment with the pads. If component is out of alignment, this can be corrected. Now it is ready to be placed. Next component to be placed is an MCU. Again, the chip is lowered to check the alignment. And the pins of the chip are aligned with the pads on the board. Now go current limiting resistors. This board uses resistors in 0603 package size. Components tend to align themselves during reflow, so there is no need to be that precise, especially with components like resistors or capacitors. There are 24 resistors of this nominal on the board, 3 per each LED. This way, the board was populated with all the components. Now it's ready for reflow in the oven. This is how finished board looks. After reflow, headers and vias were soldered and the board was cleaned in an ultrasonic cleaner. Then a program was flashed to the MCU. Now let's see how it works. When the board is held parallel to the ground, the LEDs are flashed in a rotating pattern. When the board is held like this, the LEDs indicate the rotation angle. When the board is flipped, the LEDs flash with red. The machine featured in this video is available for sale at circuit.com. Just in case you want to have a look at this board's design files or a source code of a microcontroller program, these are also available there. Thanks for watching this video. We'd love to hear your feedback. Please leave it in the comments.